Hi, this video is to talk about the fixed order quantity models. And here's our slide, and I'm going over one example. And before we go over the example, I just want to show you that the fixed order quantity, we're always ordering the same quantity of units when we place an order. So this is the reason the Q is always the same size in this figure, because as the time is passing, we place an order of the same amount, which brings the inventory to the same level. It goes down, we place an order. The order is based on a given fixed quantity. That's the reason it's fixed order quantity. And then the inventory goes down because we're using inventory, and then we place an order again, and that's the fixed order quantity. What the fixed order quantity is doing is trying to balance different costs. We have the holding cost, which is the cost to hold an inventory. As we place orders and we have inventories, we have the cost of holding this inventory. Also, we have the cost of the items, like the raw material or the products we're purchasing and keeping them in inventory. The cost, the cost, how much they cost. That's the annual cost. And we have the ordering cost. The ordering cost is how much it costs us to place orders, like having people managing all the process of placing orders. Okay, and then when we try to solve all these different costs based on the quantity, we get the optimal quantity order. That's the Q optimal based on the economic order quantity. Okay, so this is the tools that we use to determine what is the optimal quantity order we have to place every time we need to place an order and buy raw material or buy products for our company. So how much this order should be? What's the size of this order? So this is the economic order quantity um, equation, which results in a optimal quantity. Okay, and then we have the reorder point when we have to place an order during this along the time when the process is like going through the time and our inventory is going down. When do I have to reorder? So this is the tool, the equation to solve for that, and how much our total annual cost will be. Okay, so let's take a look at this example. So let's say we have to find economic order quantity. Okay, for this problem, the reorder point and the total cost. We have these pieces of information: annual demand, average daily demand, and everything. So let me show you how to solve that in Excel. Okay, you can solve this by hand. I'm going to show you how to solve in Excel. So for that, I'm going to copy those formulas and place them here as a reference for us to look. Okay, and then use that, and then let's put them here. So this is our class example. So we want to find economic order quantity. What is the Q optimal that gives us how many units we have to order every time we place an order. So according to this is the formula. So according to this formula, what we need is D, S, and H. These are the pieces of information we need. So how much is D? So we have to go back to the problem and take a look. D means the annual demand. So the annual demand is 1,000 units per year. What is S? S is how much it costs for us to place an order. It's $5 per order. So it's 5 per order. So every time you place an order, it costs $5. And H is the holding cost. How much is the holding cost? Is 1.25 per unit per year. So per unit per year. Okay. Now let's solve that. So let's solve first for the numerator within the square root. So let's do here. The numerator is 2ds, which is equal to 2 multiplied by d multiplied by s. Okay, and then we have h. I'm sorry, we can do here. Let's do here 2 ds divided by h. So now what I'm doing is the numerator divided by the denominator. So this is 1000 divided by 1.25. Okay, and finally I can do the square root. Let's call square root of above. Above is this above here, or the division. So square root of above is going to be equal to SQRT square root, open parenthesis, of this number. So the result is 89.44. So if I go back to here, this is the answer, 89.44. So I can write something like, every time I have to order, I place an order of 90. I cannot place an order of 89.44 units, so I place an order of 90 units. So we solve, so the amount of units I have to purchase to reduce my cost is 89.44 or 90 units. Okay, so I solve for that. Now I have to solve to when I have to place an order, which is given by this formula. So let's call d bar. D bar is the average daily demand. So I have to get the annual demand and divide it by the number of days we have per year. So the D bar is going to be equal to 1000 divided by 365. Let's use 365 days as a standard if it is not given in the problem. Sometimes the problem says 200 days, 250 days, and so on. Okay, so this is my average daily demand. My lead time is given here, 5 days. So it takes 5 days for me to get average daily demand, and it takes 5 days for me to get the units, the raw material when I purchased. So my reorder point is going to be equal to my average daily demand multiplied by 5 days. So my reorder point is 13.69 units. What this means is that every time that my inventory reaches 14 units, I place the order. Okay, so remember, every time I place the order, I ordered 90 units. So my inventory goes up to 90 units, 90 units. And then I start using the units and goes down and down and down. When it reaches 14 units, I place an order because it's going to take 5 days to get the materials. And then when it's going down, like when it's almost like done, I get 90 more units. Okay, so this is how you find it. The when, this answers how many units to buy. This answers when to buy the units. Okay, and here is the total annual cost.